The constantly growing universe consists of an infinite amount of celestial bodies, which are all different from each other in some way. Today, we'll tell you about one such astronomical object which never ceases to surprise and amaze the best of astronomers too. This is Knowledge Simplified, and you are watching Why Magnetars Should Freak You Out.
Now, before we get to the main question, first we need to explain to you what a magnetar is. A magnetar is a type of a special star. They are born from the explosive death of another larger star, and these tiny objects pack quite a punch. Neutron stars are city-sized stellar objects with a mass of about 1.4 times that of the Sun. But how are neutron stars related to magnetars? Magnetar is a type of a neutron star which has an immensely strong magnetic field. They are known as the most magnetic stars in the whole universe, and hence the name magnetar. Now, if you want to get a better idea of a magnetar's strength, we all are familiar about the magnetic strength of the Earth, right? The magnetic strength of a magnetar is almost 1000 trillion times that of the Earth. That's 18 zeros in that number. So basically, magnetars are the largest and the strongest magnets in the whole universe. These giants produce gamma rays that can be detected from Earth. I mean, if that's not enough, I don't know what is. So, how does a star become a magnetar?
All stars, no matter what kind, fuse hydrogen into helium deep into their core. The energy released after this process supports the stars against the crushing weight of their own gravity, and as a handy byproduct, provides the warmth and light necessary for life on any orbiting planets. But eventually, that fuel in the core runs out too, allowing gravity to temporarily win and crush the star's core even tighter. This cycle continues, and soon it becomes helium's turn to fuse, until the helium gives out too. That's where our Sun gets off the fusion train. But more massive stars can keep on chugging along, climbing up the periodic table in ever more intense and short-lived reaction phases, all the way up to nickel and iron. Soon, when even the iron or nickel finish fusing, the star begins to collapse, and very quickly a lot of changes take place, which eventually lead up to the biggest explosion in the whole universe, which is also known as a supernova. Now, this supernova event can have two outcomes. It either becomes a ball-like mixture of neutrons and protons, also known as a neutron star, or it can become a black hole. The neutron stars are mostly made up of neutrons along with a bunch of protons. The strength of gravity is so much that it even squeezes apart the atomic nuclei, and that's one of the smallest things in existence.
Now we finally get to magnetars. Magnetars have fields so strong that they can even wreak havoc on their own environment. It's so strong that laws of normal molecular chemistry don't even apply near it. Even covalent bonds cannot be formed near a magnetar due to the high intensity radiation. Research has shown these magnetars do not have a very long life, for a star that is. After about 10,000 years, they turn back into a neutron star, but are still extremely dense and extremely magnetic, but not as much as before.
Well then, that's it from us. We hope you learned something from this video. If you liked this video, consider subscribing. You can always change your mind. Make sure to tune in next time when we answer more of these amazing questions.